So the modular arithmetic, for example, mod 8, okay, we studied mod 8, we showed how to reconstruct the modular arithmetic mod 8. So we construct the addition, multiplication, and subtraction. And also for mod 8, we get the, the additive inverse and the multiplicative inverse, okay, for mod 8. For congruence, and also we studied the properties of mod 8, and we see that it's distributive and commutative and other mathematics related properties, and we have shown some examples. But for congruence, we didn't study all of the properties of congruence. For example, this property is very important. If A plus B is congruent with A plus C mod n, this means that you can say we have A here and A here. This means B is congruent with C mod n. This means B is congruent with C mod n. Okay? This is very important property, and we can use the additive inverse to prove it. For example, if I can add the additive inverse of A here, I can add minus A to the left-hand side, I minus A to the right-hand side. This means I can say A plus B minus A, which is the additive inverse of A, equal A plus C minus A mod n, or congruent. This is not equal, it is congruent. Okay? And then we can get rid of A this way from both sides to have B as congruent with C mod n. This is very important property of the modulus arithmetic. It means that we can have we can use the additive inverse to prove this. Okay, let's have an example. For example, I am trying to have an example, really. I'm trying to just invent an example right now. For example, I can take number like 8 plus 2. I'm trying to have, okay, let's concentrate on mod what? Mod 4, for example. I like mod 4. So mod 4 means that I have to subtract number from here that give me the 4. Okay, let's have this as 5. So 5 plus 8, okay, 5 plus 8 equal 13. Out of 4 means 13 out of 4, out of 8. I mean, it's 5. So I can write 5. Okay, no, this is not going to work. What about 6? Okay, 2 multiplied by 6 is 12. And this is leading to 13. So I have 1, but I cannot add 5. Okay, 5 here. Okay, let me get rid of this. Having an example is like trying to inverse the problem, to try to like reverse engineering. So, okay, let me take, this is very simple example, and this is 3, and mod 4, and 9, and 1. Okay, this is very good example. Okay, I got it. Now, I have 3 here as a common number. I can say, I can get rid of 3 from both sides, because I know now 12, this is 12, is congruent with 4 mod 4, mod 4. Because I know that 4 divides 12 minus 4, which is 4 divides 8, and this is correct. But now I can get rid of these two numbers. I can get rid of 3 from both sides to get 9 is congruent with 1 mod 4. And this is true also because 4 divides the difference between these two, which is 9 minus 1. So 4 divides 8. 4 divides 8. And that's correct. This means I can add additive inverse to both sides without affecting the congruence sign. This is just one property of congruence. I have a collection of properties. You can see them at page or slide number 22, slide 22. Slide 22 has all the properties of congruence modulo number. For example, commutative. Commutative means, for example, I will give you an example, give you what is written in the slide, W plus X mod N. I can commutate this to have the same as I can remove or change X in place of W and W in place of X, and I have the same result. This is very straightforward. X plus W mod N is the same thing. This equal to that. This is commutative. And also, okay, let me see the associative or distributive. You can see the others, they are very straightforward, no problem. Distributive like W multiplied by X plus Y mod N. You can distribute W on X and distribute W on Y. This means W multiplied by Y, okay, multiplied by Y plus W multiplied, okay, I multiplied by Y first. I have to multiply by X first, but anyway, they are equal. So W multiplied by Y and W multiplied by X mod N. This is equal the same thing. This is X.
دكتور سوري على المقاطعة بس أنا ما فهمت.
These are the properties of congruence modulus. Properties, you know.
Okay,
Do you understand
yes.
this one? Do you understand this one? This means I can add 3 to both sides, or add any number to both sides, and the congruence will be the same. There are other properties here. If you go to slide 22, you will find many properties of congruence, but I am taking just some examples out of them. Okay, you can try them. For example, you can try, for example, any example is going to work. For example, I can say X plus, I will just take general example, which is 13 is congruent to 1 mod 6. Okay, I know this because if I multiply 2 by 6, it's going to give me 12. And 12 is congruent, and 6 divides 12. Okay, I can do it like that. I can say, okay, 2 multiplied by, okay, this is, no, this is not even, so it's not going to work. I cannot write 13 like 3. It's not divisible by anything. It is prime number, so it's not work. Okay, let me have another one. 14. This is prime number. Prime number, you cannot factorize it. You understand? So this example is not going to work. Okay, let's try 14 is congruent with 2 mod 6. Okay, And we can have now 4 is multiplied, is 2 multiplied by 3 plus 4 is congruent with 2 mod 6. I can distribute, this is distributive. Distribute 2 to both sides, so I have 2 multiplied by 3 plus 2 multiplied by 4 is congruent with 2 mod 6. That's what is said in this property. Okay?
دكتور نحن كيف حددنا 2 multiply 3 plus 4
Just because I have 14 here, and forget about this number, this example, I just get it as an example. 14, I can write it as 2 multiplied by 3 plus 4, which is 2 multiplied by 7. 2 multiplied by 7 is 14.
okay
I'm just trying to have an example for this because I don't have examples in the slides. Even they said it is very easy. They said it's very easy to get some example, even in the textbook.
وصلت دكتور وصلت.
Okay,
وصلت.
so you can have these properties: commutative, distributive, and even identities or additive inverse, and we have seen how to get additive inverse. Okay, for the multiplicative inverse, I'm talking about all of what I'm talking right now. I'm talking about this sign, which is congruent modulo. They call it congruent modulo mathematics. Okay, the congruent modulo, this sign. All of them I'm talking right now, I'm talking about this sign. It's like mathematics. If I talk about plus for my child, I am explaining plus for him. So I say, okay, you can add 2 numbers like this. It will give us 3. I can distribute. So 2 multiplied by 1 minus 2, I can distribute it is equally like 2 multiplied by 1 equal 2 multiplied by 2, which is 6. I'm talking about plus for my child in the primary school. But here I'm talking about different sign. This sign is called congruent modulo. It has also some properties. I told you about many properties. I'm continuing to add you another very important property, which is multiplicative inverse. The multiplicative inverse, for example, if I have A, B, and I'm saying is congruent with A, C, mod N. I can have B is congruent with C mod N. Just because I can multiply A by its inverse, multiplicative inverse, which is A minus 1. The multiplicative inverse. So I multiply both sides by the multiplicative inverse. Just forget about this for now, and multiply A minus 1 for both sides. It's A minus 1 multiplied by A multiplied by B, all of them, equal A minus 1 multiplied by A, all multiplied by C mod N. And now I can have these are equal 0, 1, and these are equal 1. Now I can have B is congruent with C mod N. Just because of multiplicative inverse. But I have a condition here. Do you know this number N? Mod 8, mod 4, and that number, okay, let me see. Okay, let me see. Okay, A, this number. These 2 numbers should be co-prime. If they are not co-prime, we will not have an inverse. So, okay, what I'm talking about is I can have for this sign a congruent, the congruent sign, I can have multiplicative inverse, but it is not general. The additive inverse is done generally and it works. But multiplicative inverse, there is one condition to have a multiplicative inverse for congruent modulo number. This condition is saying that A and N should be co-prime. Okay, what is co-prime? Means, for example, 12 and 4, they are not co-prime because 4 divides 12 and 12 3, not co-prime, just because 3 divides 12. 12 and 5, 12 and 5, what do you think?
Co-prime.
Co-prime. Yes, co-prime.
Right.
Why? Because 12 cannot divide 5, and 5 cannot divide 12. This is co-prime. Co-prime, I told you, if you try the Euclidean algorithm, you will find that their greatest common divisor is 1. Greatest common divisor, if you try it, you will find it is 1. Okay, let's have a try right now. 12 is equal how much of 5? It is 2 multiplied by 5 plus 2. Let's get 5 here. 5 is how much of 2? Is 2 multiplied by 2 plus 1. Okay, let me take 2 is how much of 1? Is 2 multiplied by 1 plus 0. This means the greatest common divisor of these two numbers using the Euclidean is 1. This means I can have an inverse, multiplicative inverse on one condition, that A and N should be co-prime. A and N should be co-prime. Okay, let's have an example. I know this is not clear. Only if I have example, it will be clear. For example, let me take A equal 8 and N equal 6, sorry, and N equal 8. This is not an example out of my mind. It is in the slides. You can see the slides, slide number 24. Okay, you will find that example. So A equals 6 and N equal 8. And I have these numbers here, 0, 1, 2, 3, 4, 5. You know, N is 8. This is mod N. This is mod N. So I have to get 0, 1, 2, 3 until 7. Okay? And try to multiply, do multiplication, and see the result. I multiply by N, by A. Multiply by A. Let me have what is the result? If I multiply by A, which is 6, 6 by 0 is equal 0, 6 by 1 is equal 6, 2 by 6 is equal 12, 12 mod 8 equal 4, 3 by 6 is 18. Okay, let me, okay, you can use, actually you can use your calculator to have it. So for 3 is going to be 2, yes, exactly. And for 4, it is 4 by, yeah, it's 4 by 6, so it's 24. 24 8 divides 24, so the remainder is 0. And for this one is the next 6. One is 6 and 4 and 2. If you try them, you will find the sequence is repeating. If you
دكتور
see, yes.
عندي أحكي شغلة. هلا أنت بتضرب يعني 6 بصفر بعدين تقسمها على 8.
No, I get the remainder. Yes, but I don't care about the division. يعني أنا ما يهمنيش الديفيجن result. أنا يهمني الريميندر اللي هو باقي القسمة. I multiply 6 by 2 is 12. 12, when I divide it by 8, it will give me a remainder of 4. Forget about the result. I told you at the beginning of the lecture, just forget about the result. There is no result here. I just care about the remainder. Only remainder, nothing else. You just care about the result only if you want to have that remainder. To calculate the remainder, you can consider the result to find the remainder. But everything you concentrate on remainder only. So now here we have a problem here, because the relationship between the above numbers and the blue numbers, it is not one-to-one relationship. This means I can have 4 and 0 and 1 and 6 giving 2 and 6 giving me the same remainder. This way, multiplicative inverse is not going to work. I want to have unique numbers for each case of them. This way, I will have the multiplicative inverse in its correct form. This way I can check this is not going to work because there is no multiplicative inverse. 6 and 8, they have common divisor, which is 2, and not the greatest common divisor is not equal 1. This way we will not have a multiplicative inverse, and I told you why, because there is no one-to-one relationship here. But try A equal, okay, let me try another one. A equal 5 and N equal 8. If you check right now, there is no common divisor for A and 5. The common divisor is 1. The greatest common divisor is 1 because the 5 cannot divide 8 and 8 cannot divide 5. This way, I can have the multiplication the same way above and see the result. 1, 0, 1, 2, 3, 4, 5, 6, and 7, and multiply by A. Multiply by A, like that. Multiply by 5. 0 multiplied by 5 is 0. 1 multiplied by 5 is 5. 2 multiplied by 5 is 7. Is less than 8. 3 multiplied by 5 is 15. 15 to 3 by 5 is 15. Okay, let me check again. Okay, 2
دكتور الصراحة ما فهمت.
Doctor, 2 multiply of 5 is
Yes,
10,
10.
then 2.
Yes,
So
exactly.
it's 2.
This 7.
Yes, I confused you, sorry. Yes.
It's okay, doctor, it's okay.
Yeah, 2 multiplied by 5 is 10. So the remainder after division by 8 is 2. So this is 2. Yes. 3 by 5 is, 3 by 5 is 15.
Next one is 7.
Yeah, this is 7. That's why I'm confused, because I'm expecting to have only 1 7. So I found 2 7. So I see that there is a problem. Now is okay. 2 and 7 is okay. 5 multiplied by 4 is 20. 20 out of the doubles of 8. Take care. It is 2. No, this is not true. 4 multiplied by 50, which is 20.
It will
and
be
20
4.
out of 6. Yeah, 4. Yeah, 20 out of 16. The difference between them is 4. This way I have 4 here. What about 5 by 5? 5 by 5 is 25. And the multiples of 8. The multiples of 8 is 8.
It will be 1.
Yeah, it will be 1. So the difference between 5 by 5 is 25, and the difference is 1. Okay, do you understand? Is not, I don't care about only 8, the multiples of 8, because we have cycles here. The remainder means we have cycles. So 8 by 8, 8 mod 8 means 0, 9 mod 8 means 1, and also if you add 8 to 9, this is 20. So if you have 20 mod 8, This means 2 multiplied by 8 is 16, so it is 4, as we said here. Okay, now 5 by 6, which is 30,
6.
so it's 6 out of 24. And the last one is 5 by 7, 35. And you can add the 8 here, you will find it 32. 32 out of 35, it's 3. Okay, let's revise now. The condition is to have one-to-one relationship. You see 0, 5, 2, 7, 4, 1, 6, 3. There is no repeated number. This means the relationship between these numbers and those numbers is one-to-one relationship. One-to-one relationship. This way I can have the multiplicative inverse for that A. I can have the multiplicative inverse of that A. Okay? Just because A and N, they are co-primes, they don't have a common divisor, only they have a common divisor of 1. Okay, let's move to another important property, which is, you can say, yes.
بس ما كملت انت السؤال.
سؤال
ما
إيه؟
ما طلعنا الانفيرس.
Inverse for what?
ال A5 وال N8.
طيب okay, you can try
يعني بس
any,
احنا شفنا اذا هم برايم.
ها؟
انت بس شفت يعني اذا هم كو برايم ولا لا.
No, I'm trying to tell you that if I have 2 co-prime numbers, I can get the inverse of that number, of A. Okay, let's have an example. I'm just describing a property, not giving an example. So let's have an example. For example, yes. So I like that one, 13 equal 1 mod 4. Okay? Let's have the inverse. I don't have inverse of 5. Okay, let's have 5 multiplied by 13. But this is not for mod 4, mod 8. I have to get mod 8. So this is not going to work because mod 8, 12 is not. Okay, 17. What about 17 is okay? Okay, this is going to work, no problem. Let's have a try. We can try 5 multiplied by 17 is congruent to 5 multiplied by 1, mod 8. If you try this one, you will find it's okay. I don't like multiplication, but I will do it for now. 53, 1 by 5, 8, okay? If it is not correct, please tell me. So it's 5 mod 8. So 8 should divide 85 minus 5, which is 8 divides 80. That's correct. Now, I can have the multiplicative inverse. This means I can get rid of 5 from both sides. And I have the same remaining property. So, for example, if the example from the beginning giving me something like that, 85 is congruent with 5 mod 8. Can you minimize this? This is a question. He asking me about minimizing this.
Yes,
question.
doctor.
I can minimize it because I can get rid of these 2 5s. I can have 85 multiplied by 5, which is 17, is congruent with 5 divided by 5, which is 1, mod 8. I can do that, but I can do that, and it is correct. Just because I know that I want to divide by 5, and I know that 5 and the 8, they are co-prime. This way is correct. But if they are not co-prime, I will not be able to have this correct relationship. Okay, so if I get in exam, in test, and I have this property, or this expression, he's telling me 85 is congruent with 5 mod 8, this means I can minimize the equation here by dividing by 5, because I have a multiplicative inverse of 5 here is working. Why it is working? Just because 5 and 8, they are co-prime together. They don't have a common divisor. So I can minimize this to be 17 is congruent with 1 mod 8. And this is the answer. There is no more minimization than this. Okay, this is an example. You understand now? Okay, now, any question? Any
No,
question?
Doctor.
Okay. Okay, now we move to prime numbers. Very quickly, I want to finish as early as possible. Let me see the prime numbers. The prime numbers, like 2 is a prime number, 3 is a prime number, 4 is not a prime number because 2 can divide it. But now I don't know what is a prime number exactly. The prime number like 7 is prime. Why it's prime? Because
5
6,
also.
yes, I know. Yes, exactly. So 6, okay, cannot divide 7. Is not divisible by 7. I mean, 6 cannot divide 7. This is 6 cannot, or 5 cannot divide 7. 4 cannot divide 7. 3 cannot divide 7. 2 cannot divide 7. Only 1 is dividing 7. Only 1. This is correct. But for the others is not correct. This is a prime number.
So, Doctor, we can say the prime number is the number who can only be divided on 1?
Yes, exactly. Yeah, that's the exact definition of prime numbers. It has a divisor of only himself and 1. Itself and 1, okay? So it can, for example, 7 is divisible by 7, and 7 is divisible by 1. This is correct, without any remainder. I'm talking about remainder. There is no remainder here, no remainder here. But if you take any division from this, for example, 7 over 3, you will have a remainder. Okay, so this is the definition of prime number, and I think this is not a big deal with you because you have heard about prime numbers many times during your education. But also in the primary school, they said, okay, can we have for example, the greatest common divisor? Can we use prime numbers to calculate the GCD, the greatest common divisor? Yes, we can. We can have that. Let me have an example for this. Let me have an example for this. Okay. What about the 55? Okay, greatest common divisor of 55 and 22. Do you know the answer? Anybody know the answer? Anybody knows the answer? This is straightforward. Do you know the greatest common divisor of 55 and 22?
11.
11, yes. It is very straightforward. Now I want to use the prime numbers to calculate the greatest common divisor of these two numbers. What you know, or what is important about any number? Okay, before solving this problem, let's get to very important property of prime numbers. I can write any number. For example, I write 55 as a collection of prime numbers. Multiplication of prime numbers. Any number can be a multiplication of a collection of prime numbers. Okay, let me take 10. 10 can be 2 multiplied by 5. 2 is a prime number and 5 is a prime number. Any number is okay. 13, what about 13 is 1 by 13 because it is a prime number. There is no other divisions. What about 20? 20 is equal to 2
10
multiplied
2 5.
2 by 2 by 5, right? 2, it is 2 to the power 2 multiplied by 5 to the power 1. This is 20. So you can write any number as a multiplication of prime numbers. So what about 55? 55 can be written as 5 by 11. 5 is a prime number and 11 is a prime number. What about 22? 22
2
also,
and 11.
yeah, 2 multiplied by 11. 2 multiplied by 11. Here I can say, okay, this is 2 to the power 0. Do you have a problem with this? Multiplied by 5.
Yes, we can say also 5 power 0.
Yeah, so 5 to the power 0. Because this is 1, 2 by 1 by 11, and this is 1 by 5 by 11. Then if I want to get the greatest common divisor, I get the minimum power. Okay, minimum power. So the greatest common divisor is GCD of 55 and 22 equal, this is the minimum power. So it is 2 to the power 0. And this is the minimum power multiplied by 5 to the power 0. And here we have anyone is okay because they are equal. So it is 11 to the power 1. This means 1 by 1 by 11, which is 11. Okay? This way I can use the prime numbers to calculate the greatest common divisor. I told you about the Euclidean algorithm. This is one, and the second one is to use prime numbers here. There is also some theories like Fermat's theory here. Fermat's theory saying that if I have A raised to the power P minus 1, while P is prime, I can have this number is congruent to 1 mod P. 1 mod P. Okay? And also I can write this one as is better to write it this one, and I will give you an example, don't worry. About A to the power P is congruent with A mod P. Don't ask me about the proof, okay? Don't ask me about the proof. Ask me about example. Okay. Here I can give you an example. You know, this is a prime number, and this is also must be prime number. They are equal. This is P and this is P. So P should be prime number. This is the most important condition here. For example, if I take 3 to the power 2 is congruent with, I have 3 here, I can say 3 mod 2. Let's check this if it's working or not. Check it, just to check it. I have 3 to the power 2 means 9. It's congruent with 3 mod 2 just because 2 divides 9 minus 3. 2 divides 6. That's correct. Okay, this is an example of Fermat's theory. Just because exponentiation is very important in our cryptography algorithms. Maybe sometimes you have big numbers and you can have it like exponent of many numbers, or 20, something like that. You will be faced with big numbers, and you can simplify your calculations using the Fermat theory. Okay, are you with me? You following up with me? Anybody there?
Yes, doctor.
Yes,
Okay,
doctor.
yes, okay. Because it says that I have been signed out, so I thought you have left. Okay, now it's okay. Okay, so for now, you understand the Fermat theory just to have the power, to use the power like that, simplify the calculations. I can work just to give you the exponents, simplified form of exponents. Okay, okay,
Doctor,
yes,
but you write the first, that's a to the power p minus 1. And here
yes,
it is, we have 2 and there mod 2.
yes, but this is an example of the second form. Example of the second form, not for the first form.
Okay,
Okay.
what is the difference between first and second? If it's 1, okay.
Yeah, this is one, not A.
Okay.
Okay, so this is just to keep it like that. This is more important than that. I will use it. I will use this, but I will use it, but not frequently. Okay. Okay, let's move to new topic, which is many topics today. Totient functions. Totient function. Totient function is really easy. You know, this is the number theory is easy. Just if you try it many times, you will find it's very easy to understand. It's not comparable to differential equations or calculus or linear algebra. This is very easy. This is very easy type of math. Even you study it in the primary school. So don't worry about understanding everything. If you try by hand, many questions, many examples, you will find it very easy to understand. Okay. Now about the torsion of numbers.
Sorry, doctor, for interrupting, but
Yes.
we don't have lab class.
You have lab class, but it will start at 2:30.
Okay, now it's 2:30.
Now it's 2:30.
Yes. Yes, because I'm calculating the time due for KSA, for Saudi Arabia. Okay. Anyway, you have a lab today. What will we do? Okay.
Doctor, it will be you?
I'm stopping here. Okay. The lab, you're asking about the lab?